Hello and welcome to the continuous testing webinar with software testing statesman Paul Gerrard, and I'll be your host, Simon Knight. This continuous testing webinar is the first part in a two-part series during which Paul is going to talk about the issues facing testers trying to implement continuous testing strategies. In part two, we're going to focus on the automation aspects of continuous testing. And in this webinar, we're mainly going to cover the contribution that testers make in a continuous delivery environment, what continuous delivery and continuous testing actually mean, both in theory and in practice. Paul's going to talk about a new model for testing in a continuous delivery context. And he's going to take us through the whole continuous testing process, right through from planning that testing to actually delivering and executing the testing, while at the same time continuously understanding everything relating to the requirements and the project that you're working on, and the testing and all of the aspects that compose the testing that you want to achieve. Once Paul's done, we will hopefully have time to take some questions. We do have a few housekeeping announcements. As usual, we'll keep everybody on mute throughout the entire webinar. If you've got any questions or comments, please do feel free to share them in the chat room, and we'll try to pick those up where appropriate during the webinar itself, otherwise at the end during the Q&A session. If we don't get around to answering all of the questions, we will try to address them in a subsequent FAQ style blog post. And just to mention that we will be recording the webinar and we'll share it with you via the blog and also on YouTube, usually within a day or so after the webinar itself. So I'm Simon Knight, I'm the TestRail product manager. If you've got any issues, questions, feature requests, suggestions, etc., about how we can improve your TestRail experience, please feel free to reach out to me directly. Before I became a product manager, I spent 10 years or so working as an independent software testing consultant, working with teams of various shapes and sizes, helping them deliver better software faster and with less bugs. I also worked a bit with the Ministry of Testing and various other places as well. If you want to stay in touch, you can do that via the blogs, LinkedIn, or on the socials. And also today we have Paul Gerrard with us. If you've been around the testing circuit at all, you'll recognize and will probably have heard Paul speak, keynote, train, or chair at various conferences. He's also been organizing and hosting the regular test management forum, now called the Assurance Leadership Forum, certainly for as long as I can remember. So if you need somebody to speak, train, or write about testing, Paul is your man, and you can find him via the links provided. So without further ado, I am going to hand over to Paul to take us through continuous testing. Paul, I'm going to hand over control to you.
Okay.
Now, once I find your name on the list. There we go. Over to you.
Thanks, Simon. Okay, so thanks very much for that. So I'm just going to go straight into it and talk about continuous delivery, just to remind you if you already understand what it is. But if you are still finding your feet with this whole concept of continuous delivery, I just need to sort of summarize it so we're on the same page, needless to say. So the idea with continuous delivery was that it supports rapid iterations of delivery of software into production environments. Now, pretty much we're talking about online systems and obviously mobile applications and so on. And the principle that's being attempted to be applied, if you like, is we have what you'd understand as traditional delivery of a whole series of releases, but spread over possibly months, you know, in the waterfall world, or in periods of 2, 3, 4 weeks or even more. And the concept of continuous delivery is to reduce the scale of every iteration to the point where it literally can be defined, built, tested, and deployed within days. Some companies are going as rapidly as multiple deliveries in a day, and that's for some companies, but obviously not many. But the principle is that by slicing the scope of the release into smaller and smaller iterations, we get some benefits directly. I mean, firstly, we're being less ambitious each time. We have a much smaller scope of delivery. And the principle from that would be that if we take on such a small piece of scope, then the risk of failure usually is reduced, the first thing. Also, if we make an error or a screw up or whatever, the rollback of a smaller implementation is more straightforward than taking a huge deployment and unwinding it back to a previous state. Now, the underlying assumption with continuous delivery is that we have automation at almost every stage we can apply it to. So pervasive automation of certainly the whole notion of regression testing, the requirement to create environments, virtual machines, database and application builds, and to run and deploy unit integration tests and so on and so forth. It's all automated. The whole idea is that we rely on automation to do all these mechanical activities for us. Now, the challenge we have is that with testing requires some thought, like coding, but whereas the coding has its kind of time box, to be done, testing tends to come after the coding, and we get squeezed just like in waterfall and staged environments, in that testing requires some thought, but it also requires some manual testing, some exploratory testing, so for sure. And what tends to happen is in initial implementation of continuous delivery, that testing gets squeezed, but the testers are kind of forced to do things in a great hurry because they simply haven't got the time usually to implement the testing they would feel more comfortable with. And applying automation is a bit stressful as well, because the software isn't ready for automation until it's really quite mature, and that's only in potentially a few hours or days. So we have a real challenge of in continuous delivery of testing not becoming a bottleneck. So the way that people often describe or illustrate how continuous delivery works, you'll see a whole range of models, but and I've tried to sort of spin through them fairly quickly, but the one that's most common is this kind of figure of 8 or infinite loop, if you like, infinity as a symbol. And it's kind of obvious from the appearance that, okay, there's a whole series of activities in order. And on the left is kind of the development side of it. And on the right is the release, deployment, operate, and monitor in production, and use the outcome of monitoring to influence the next iteration of the system. But what I want to do is just step back from that infinite loop and, if you like, unwrap it and just try and just demonstrate that actually thinking about continuous delivery in that way is helpful for a few moments, but it's not actually how it really happens. The automated processes, sure, they do happen in a continuous sequence, but the activities of the developers and testers and the people in the team who are contributing their knowledge and thought tend to jump around a lot, between activities, between understanding requirements, getting some code together, unit testing, and the system and other integration testing that the testers might implement. So what I want to suggest is actually, I don't like this idea of the infinite loop with a whole series of 8 stages and going through it again and again and again. It smacks of waterfall again, waterfall thinking. And you know what? I thought we'd kind of left that behind with Agile, and it's kind of come back into our horizon, on the horizon again. So I just want to explore the consequences of thinking in a sequential way, just for a moment. Now, one thing that is part of this process is the whole idea of automation, and we have this kind of test automation pyramid, which I'm pretty certain most of you will be familiar with. But I have a real problem with this. It kind of makes sense that we have lots of unit tests, scaled at the bottom, by developers creating their with unit test frameworks and so on, and integration or service level testing using APIs. GUI tests, we do fewer of those because they are harder to get right. We have less time and so on and so forth. A manual is kind of this kind of cloud at the top. Well, I would compare that directly with the V model, the good old V model. It's structured, sequence, stage testing right through the life cycle. It's the same idea, and this discomforts me somewhat. So I don't want to dwell too long on criticizing these models, but I just want to say the reason that we overcame the problems, the way we overcame problems with waterfall was that we decided that Agile is the way to go, and that a collaborative approach where you have a multidisciplinary team constantly talking, collaborating, communicating, giving feedback and so on. It's through that communication in its complexity, and it is a complex process, that's how we deliver. The problem is, if we think about continuous testing, it's more of the same. It's even more kind of dynamic, if you like, is the way I would look at it. And I've just made some notes here, and the reasons why sequential thinking, or stage thinking doesn't work in a continuous process is exactly the same as why it was troublesome in the first place in waterfall. In that it's sequential, one stage follows another. You don't have any choice. You can't jump around. There's a dependency between each of the stages, which you can't violate, if you like. It's not re-entrant. You can't come into the sequence of stages in the middle. Having discovered something late, it's very complicated to unwind people's thinking and restart the process somewhere in the middle. There's only one phase of testing, so testing appears in a lump at the end. Well, we know that testers' contribution is spread through requirements, working in parallel with the developers as they write code and build their own unit tests, and also later on when you have a testable system to manually test, if you like, and explore. So what I want to suggest is that this sequential thinking doesn't work for continuous delivery. So in the broad, although Agile has taken, what is it now, maybe 17 years, I think, when the first thoughts about Agile, just before the manifesto came out, but we've been thinking about Agile for 15, 16, 17 years now. And it's taken a long time for testers to find their feet, because the initial implementations of Agile almost didn't have a role for testers. And we know things like BDD has helped somewhat, because it allows developers certainly it eases them into a test-driven approach. But BDD isn't just about testing, it's about the collaboration, the whole three amigos kind of idea of analyst or user, developer and tester. So BDD has helped the tester to understand their role in life, if you like. But continuous delivery really, ramps up the temperature on the processes we're following. And most people's reaction to this has been to shift testers left, to not have an independent, separate team of testers, rather to embed them with developers to work collaboratively and continuously. So that change, the shift left, the redistribution of testing and responsibilities for testing, that requires us absolutely not to think about testing in a staged way. So this is my introduction, if you like, to this kind of idea I came up with a few years ago about a new model for testing, a new way of thinking about testing. And it's really about how we think and how we understand. So one little sidebar I'd want to introduce is that when I talk about testing, and I'll talk about modeling a little bit as well, what I'm really talking about is understanding the requirement to the degree that you can trust it, and understanding the system through testing, exploration, and test execution, understanding what it is capable of and what it is not capable of. So I'm tempted just to almost drop the term testing in some of the talks I'm giving nowadays and use this word understanding, because actually that's what it's about. It's about the team understanding of the requirements through delivery, deployment, and operation in production through monitoring. So I quite like the idea of this notion of understanding being the foundation of everything we do as a tester. But I'll park that again. I'll come back to this idea of understanding soon. So in order to think more differently about what testing is and how it operates, is we need a new model. And what I'm going to suggest is we need a new model for testing which is free from logistics. And I'll explain what logistics are in a moment. I want to talk about models just for a second. Again, as a little sidebar, as a little foundation for the stuff that's coming. Imagine you're this guy here and thirsty, and you need to walk a few steps in order to pick up a glass, take a drink of water, and not dribble it down your chin. If you imagine, the brain has to control, I'm told, around 100 muscles in order to take a step and to walk. And so the brain, second by second, but much faster than that, has to understand the configuration of the major bones in our body, our arms and legs, and the angles of joints and stuff. It has to understand the tensions in all those 100 muscles, and it has to send nerve impulses to those muscles in an orchestrated way in order to walk a few steps. Now, our brain simply isn't fast enough to do that. But what our brain does in a remarkable way is it kind of simplifies the problem using some magical modeling technique. And I'm not going to suggest I understand how that works. But what I am trying to suggest is the process of simplification of something terribly complex, like how I take a few steps, is done by the brain as a natural, intuitive, perfectly comfortable thing. If we are, able-bodied, it seems to be a perfectly natural thing we have to do. So I want to suggest that our brains are very, very effective modeling machines, and we don't take advantage of the capabilities of our brain when we write code, when we test code. So modeling is how we understand complexity, and is that word understanding again. So take it from me that when I talk about model, you could substitute the word understanding for every use of the word model in what I'm going to say in the next few minutes. Now, one other minor thing I need to say is that our sources of knowledge, which is what we base our design of software on, and when we write code, but obviously also our testing, is we depend on maybe documentation, specs, standards. We get verbal instruction from our users. We may have experience, good or bad, of testing similar systems. We may know the business process already. We also have our intelligence, intuition, beliefs, biases, prejudices, all our fallibilities as human beings as well. And all these sources of information, and we usually have several on every kind of aspect of what we do, is we have to make judgments on how we make sense of potentially conflicting requirements or gaps in requirements. Our sources of knowledge are fallible and incomplete. That's what I want to say. So let me kick off. For the next few minutes, I want to suggest that you forget logistics. And by that, I mean, this is how I'll put it. I'm going to say that for the next few minutes, I don't care whether you document your tests or not. I don't care whether you execute your tests using automation, or you do it manually, or use some other piece of magic. I don't care what process you follow, Agile, waterfall, continuous, I don't care. I don't care what business you're in, whether you're in telecoms or banking or health or government, whatever, don't care. And I certainly don't care about what technology you're using. Now, the reason for doing this is when we start to accommodate the notion of documentation, that forces processes and behaviors onto us. And what I want to talk about is how we think about testing, because I think that is common to everyone who tests, and I think it is common to every context of testing. And you can argue with that and say, well, wait a minute, what about, surely healthcare requires a different set of disciplines from banking? Absolutely. I'm not saying the thinking itself is the same, but the processes, the modes of thinking, I think are common. And we think differently depending on the context we're working in. So let me make this statement from the top of the mountain, which is this idea of all testing is exploratory. And what I mean by this, what I mean is we explore our sources of knowledge. we try and make sense. We try and understand the definition, if you like, of the system to be tested. And what we do is, in order to understand, we build models. We can call them test models or just models. Developers make models too in their minds, just the same. And what we do is, when we think we understand, we use those mental models to inform our testing. Okay, so the view from the top of the mountain is we explore source of information, source of knowledge, to build mental models to understand the complexity, and we use those mental models, whether they're written down or not, I don't care. Those mental models inform our testing. We derive useful, meaningful tests from that model. So what I'm going to do now is just go halfway down the mountain and just sort of, give you a slight bit more flesh on the bones. We have these two modes of operation as testers. We explore our sources on the left. We create models, test models. And on the right, we have this idea of using those models to test, okay? And at some point, what happens is we read, we interview, we study, we analyze, we do whatever we need to do to understand the definition of a feature, say. And at some point we think, aha, I think I understand enough in order to write some code. I think I understand enough to test some code. Our models are adequate. So we flip from the left of exploration to the right, which is the testing side. But very often we discover that when we start testing, we realize our mental model isn't quite right. The requirements might not be complete. There might be conflicts in the requirements. There might be ambiguity. There might be gaps. So although we want to be on the right doing the testing, we discover through testing that actually our models are inadequate and maybe our requirements, our sources have let us down, and we have to go back to the user to try and clarify requirements. And that's a very natural thing that every tester does, every developer does. Finally, we have this blob in the middle called judgment. And I can't tell you how that judgment works, except I know we do have this judgment call to make, which is our models are good enough to write code, to test code. That's what I want to say. Now, the question arises now is, well, how do developers think the same way? Well, I think their goal might be different, to write some code, but their need to create mental models to understand complexity is exactly the same. And so developers and testers, I think, have a much more common set of behaviors and thinking behaviors, certainly, than you might realize. Now, of course, you might say, well, developers have a different goal to write code. Well, wait a minute. They also have to test that code. And you could say that it's the tests that, passing tests is their actual goal. So I think the goal of testers and developers is not necessarily the same. They will come up with different models, perhaps, and that would be sensible. But I still want to say that I think testers and developers think in a very similar way, certainly on the left-hand side, on the modeling and understanding side. Now, I could spend another 10 or 15 minutes explaining the model in more detail, but what I want to do is just drop it in front of you and just say there are 10 thinking activities, from inquiring, modeling, predicting, challenging, and so on and so forth. Everything ends ing on this model. And if you want to see a fuller explanation, there's a webinar I did for Agile Testing Days earlier this year, which I think is probably the best exposition of it. So if you want that level of detail, just follow the link to that webinar. There's also a paper which might be of interest to you too. But what I want to suggest is that this model reflects a set of real activities. So the way we think about a requirement when we are inquiring, let's say, reading a requirements document, that activity of gathering, that's the information gathering activity, asking questions, reading, sketching pictures on the whiteboard, sharing, all that kind of stuff. That one activity might be reflected as a physical activity of drawing models, of underlining text in a document, of summarizing a requirement in a picture or a flow chart or something like that. Okay, so what I want to say that the thinking activities are consistent for all testers, but how you implement it, the logistics varies with every project. Okay. Now, another thing to say is there are 10 activities on the diagram. There are 10 of these: inquiring, modeling, informing, applying, whatever activities. And our brains are so good, very often we're running these processes in parallel. Okay, so we might be thinking about gathering a requirement for one feature. We might be thinking about defining the model for another feature. We might be testing another feature. And in a dynamic environment with continuous delivery, the testers and developers are doing lots of these things almost at the same time. And events happen, their phone rings, you have to answer it. You have to make a judgment of where am I thinking right now for each of the features requirements that we're working on. And so I want to suggest actually the way we think about the status of features, coming through as say a user story perhaps, is what we are thinking about with respect to that feature is its status. Now I know that the status might be, well, it's the developer's coding. Well, that may be, but what are we thinking about? And I think it's what we're thinking about that actually defines the status in a more consistent and reliable way, a meaningful way, I have to say. So if you like, what I'm trying to suggest is that rather than being a series of staged activities, there's a whole lot of very dynamic event-driven activities going on. It's not staged in the good old bad old days of waterfall. So I want to illustrate this by just thinking back. I mean, some of you will be experienced enough to have tested green screen, mini computer or mainframe applications back in the day. And if you recall, on a simple screen, you enter the screen in the top left field and you tab through the fields, filling in data, and you've got to enter the data in a very specific sequence, and you can go forwards and you can go backwards. So a flow chart of, if you like, a model of that process would look very straightforward. It's very kind of sequential in that way. When GUIs came along, when Windows applications came along, we could enter data into screens in any order we like, just by clicking on the fields in the order we want. So suddenly testing got much more complicated because of that, because the number of paths and permutations, combinations suddenly exploded. And I want to suggest that what I'm trying to talk about with continuous delivery is it's like an event-driven application. There's many ways in, many ways out. It's not easily described in a sequential process, and that's why I think the mental modeling I've done with my new model of testing is how I think we ought to think in the future about testing, but in development in general. Now, one of the ways of looking at it is if it is truly event driven, those events are what? Well, they could be failures of an automated process of a deployment or some testing, or it could be one member of the team asking an awkward question to another member of the team, and the answer is, I'm not sure. Each of these is an event, and we have to deal with it in our process, however it is defined. So when we come to the tester's role, I think there are three main challenges, and this is how I would summarize the difficulty we have with testing in continuous delivery. The first one is, how can we trust test automation to assure delivery? How do we trust tools to do what testers used to do? Now, in fact, tools don't do what testers used to do. Execution is not the entirety of what testers do at all. But we still need to apply some trust to the automation that we are using. The second challenge is, where and how do we do necessary, as I would say, manual testing? We're trying to do as much as we can with automation, but we still have to do what you might understand as manual exploratory testing. But it's exploration with our brains, not our hands, you could say. And the third one is, how do testers interact with other members of the team? Because the questions come from all directions. And I'm sure, I can't see you, but I know some of you will be nodding and saying, you never know what's coming next. You never know what's around the corner. And how do we deal with this? It's a very dynamic kind of environment. So going back to our infinite loop model, I want to come back and just suggest where the testing actually happens. And most of the test activities, in terms of definition of the tests, happen in what you'd understand as to be the planning stage. Creating tests by testers, if not developers, that happens in parallel with coding and the build process, if you like. And then the test phase, which gets a good chunk of this diagram, is intended to be largely automated. So actually, in terms of its span of this diagram, it should be very short. It should be like, a centimeter, not 10 centimeters. It should be all over and done with in minutes, not hours and hours and hours. So this diagram does not reflect the attention paid to each phase. The stuff on the right is very much in the automated kind of world, and the stuff on the left, apart from the testing itself, the test execution, is where all the people and interactions and collaboration happens. So it's not a good reflection of what actually happens, this picture, I'm afraid. So I just want to sort of leave that behind and just move on a little bit. So I'm going to talk about the left-hand side of my model, which actually covers the scope. If you look at the bottom right, covers the scope of plan, code, and build. Okay, that's in effect where that left-hand side fits. So I've suggested already that in terms of any feature that's coming, let's say, the way we think about it, whether we're inquiring, asking questions, modeling, trying to understand, predicting, using our model to derive interesting scenarios, examples, challenging, using those examples to challenge our sources of knowledge to say, is this really what you want the software to do? Informing is about informing the design of tests, and refining is where we refine our model. That we've got some experience of execution, and now refining the model is our goal. So I want to suggest the status is actually how we think about each feature. And I just want to just very briefly just go through each one of these. I'm just going to talk about, if you like, the last bullet of each of these slides. We're inquiring. This top left kind of process circled, we are still gathering information on the requirements. We're still asking questions. We're still reading. We're still taking information in. We might be actually exploring the system itself, the delivered system. We might be exploring the old system to understand what it did and use that as an oracle, if you like. Modeling is where we are assimilating the information gathered. So we're trying to understand what the requirement actually is, the need actually is, if you like. So modeling is where we're trying to assimilate information and understand it. Predicting is where we can come up with examples derived from our model. We understand the requirement now. Now we can come up with some interesting examples, potentially to go back to our users. So challenging is where we believe there are anomalies in requirements, in our sources of knowledge, and we have some examples that expose gaps or expose ambiguities and so on and so forth. And we're also, thinking about what could go wrong, and looking at risks and tests and priorities with conversations with stakeholders, whoever they are. So challenge is that one. Informing is where we trust a requirement. We've challenged the requirement. We've got some refinements now. We understand what the requirement is, and we have a model, a mental model or a written model, if we write it down, that we can derive tests from. So we can start to build meaningful tests from our model. Now we do this whether we are doing scripted or exploratory, as it's understood to be, testing, okay? We just do it all in our head. It happens very quickly, but nonetheless, it's the same thought processes. The thinking is different, but the thought processes are common. So with this idea of continuous collaboration, each of the thinking activities I've tried to identify on the left exists, and it doesn't matter almost who does it. There might not be a tester involved at all. So the developer has to take responsibility for challenging requirements to getting to the bottom of what those requirements are. But more likely, we have this idea of the three amigos, the three viewpoints from a business analyst or a user, a stakeholder, if you like, then the developers, and then the testers, and we contribute different aspects to the collaboration. It's a series of responses to events and interactions between people, and this is how we're driving requirements through the pipeline, by continuously talking, acting on the information we have to write code, to build tests, to understand tests, and so on and so forth. The tester's role is probably they're going to be leading on challenging the requirements, because we're all pedants. We need to understand with precision what a feature might need to do. We're also probably the person thinking most clearly about risks and the notion of coverage and how much testing is enough, and so on and so forth. So although it's continuous and it's split between people, the testers probably got a bit of an agenda to look at very specific aspects of the process. So I've suggested already that when we look at status, we could say, well, where is the feature in the pipeline? Well, it could be in planning, coding, or testing, building, that kind of thing. But actually, I think it's more helpful to think about well, what do you think of this feature now? And the developer might say, I'm ready to build, I'm good. I'm actually writing code. But the tester might say, oh, hold on, wait a minute. I've just found an anomaly and I've got an example which illustrates a real conflict in the requirements. And I'm going to try and get some time with the users this afternoon, maybe. And so understanding that there's a schism in the project, if you like, where developers might be more advanced in their thinking than the testers, and the testers are right, and therefore you have to go back a bit, or the developers are right, which could happen because they've had a conversation with the users without the testers present. Who knows? We have a mechanism, a way of identifying anomalies in people's thinking, and by so doing, we understand anomalies in the definition and the construction of the software. So when we ask about status, I would say, what do you think of this feature at the moment? Not where is it on a Kanban board? That's not as helpful. So really what I'm headed towards is the whole notion of what testers are doing is they're trying to continuously understand the definition of a requirement and then the implementation such that it can be tested. Okay, so the goal of the left-hand side of my model, and certainly the left-hand side of the early phases, the planning phase in particular, is the goal is to trust the requirement, to arrive at an agreed common definition of need, so that the developer can code with confidence and the tester can create tests with confidence. In the kind of code, build, and test phases, the tester naturally is still thinking about testing, but probably waiting for something to be delivered that becomes testable itself. So they're thinking about the definition of tests so much as much as actually doing any testing. And the whole notion of responding to events and collaboration through stand-ups, pairing, constant communication, it's continuous communication, continuous feedback, responding to events, failures in automated processes, failures in manual testing, if you like, but also questions and answers and responses from users, developers, and the testers themselves. So it's a very dynamic kind of environment. So the two phases I would say is I understand the definition, understand the delivery, and that's how I would summarize this idea of what testers do. It's all about understanding. So, okay, I'm coming to an end. So I want to suggest this, that continuous testing, as it's often described, at least initially, as a sequential process, is kind of flawed and misleading. It doesn't work that way. I would argue very strongly that before we commit to writing code, we should understand the requirement. And this is a very old-fashioned view. There's nothing new about this at all. But the thing is, if we're committing to coding and automated testing, we have an opportunity to get both the code itself functionally correct, but also the tests to be meaningful in parallel. And automation where the requirement is stable, the code doesn't change as much, and the tests can be well defined, that's the place we want to be with test automation. We have to trust the requirements and have a shared understanding of the definition. Now, development and testing is based on similar models. I've said the same on the slides, but what I'm trying to suggest is the developer thinks differently about requirements than the tester because they're a programmer. They're trying to construct code. The tester's trying to construct scenarios to exercise code in a systematic way to understand how it behaves. So tests and requirements, our models, represent our understanding. It's a very dynamic process, so I don't think we can use any kind of staged description of the process. We have to be very reactive to events. It's the thinking that matters, not the processes or stages or status of a feature on a Kanban diagram. The goal of testing, I'm going to suggest, is better team understanding. What we're trying to achieve is the team to understand what it's trying to do and then understanding what it has done and delivered. And I guess with that, Simon, I'm kind of done.
It seems that way. I'm just trying to figure out where my Chrome has gone again. It seems to have disappeared. Are we seeing my screen?
I think so, yeah.
Yeah, okay, awesome. So great presentation, Paul. I think there's a lot of stuff in those slides to really kind of dig into, and probably I would want to watch the video and go through all of those again at leisure and kind of think about some of the stuff that you've presented there, Paul. A lot of the questions that we had during the webinar related to the video. So
yeah, I can see.
Just to reiterate, the video will be shared once we've gotten the download from GoToWebinar, and we will be posting that on our blog. And in due course, we'll be sending out a link to the blog post in our newsletter emails. So if you're not signed up for those emails, then please go to the blog and sign up so that you get notified of the new blog post and the excuse me, the video once it's actually hosted on there. We didn't get a huge amount of questions, Paul. So I'm gonna buy. I think that's probably a good thing. It means that you must have covered off all of the information in your presentation and talk itself.
There are a few. I went a bit too fast.
There was a lot in there to be sure. I mean, one of the things that I picked up on just from looking at the infinite loop model that you presented towards the end of the presentation was all of the testing seemed to be taking place prior to release into production. And I know that there's kind of a school of thought that suggests we should be testing in production as well. So I kind of wondered where you stood in that regard.
I think, well, so testing in production could be a tester going into the live system, exploring features, looking at how they behave, and doing what you'd understand as tests. And the reason for doing that would be if the production environment is richer in terms of the data that's there, and there's value in learning what the system will do from the data that's in the live system. It's becoming more and more common that the data in production systems is so much bigger and variable and expansive and diverse compared with our test environments. Because if we're doing sort of many builds in a day, it's not always easy to create gigabytes and gigabytes of data in databases as promptly as you want to run your automated processing. So there is value, I think, in doing that. There might be things that you feel that, as long as it's a safe thing to do and you're not going to screw up any users' data, of course. But the other angle is I'm tending to think nowadays that the monitoring that goes on in production systems is actually a form of testing, in that it's about gathering data that describes the behavior of users, that describes the behavior, reliability, performance of the systems itself. And I see it as an extension of testing. Now, it might be that some people out there listening now would say, well, hold on, that's the role of the ops guys. They do all that stuff and they talk to marketing and they figure out what to do next. Well, that's fine. Okay, maybe there's no tester involvement, but I see it as a test activity, and kind of that's part of the thing. Part of the content I think will be in part 2 of the 2 presentations. So I will talk about that a little bit. But testing in production. Oh, sorry. Carry on. Sorry.
I was just going to pick up on a couple of points in your answer there. So certainly in terms of the production data side of things and the scope of that data versus what you might have in your testing, your UAT, your development environments, etc. I think that increasingly is a challenge, replicating production type data in your testing environments. And that's a challenge I think that's been highlighted in recent industry papers like the World Quality Report and probably some other papers as well. And the other thing as well, I guess, in terms of testing and production, and the idea that that's kind of more of a sort of DevOpsy type role, is that I guess the trend that we see in the industry that testing is an activity, right? It's not necessarily a role anymore, and testing can be done by any and all of the people on a project team.
Mm-hmm.
So,
I think one of the uses of the new model idea, there's these 10 activities, is to ask the question, well, who's going to do the challenging of the requirements? And if no one nods their head, we've got an issue. Someone needs to take that responsibility in order to test the understanding of the definition of the feature, say. So I think of the different modes of thinking partly as a way of you can use it as a kind of a checklist that who's going to do the definition of the tests, who's going to do the informing activity, if you like. But the other angle is when you have a conversation. Certainly, I've had conversations with developers and testers, in their teams, where you ask them and say, "Well, where's your thinking?" And the developer might say, "I'm writing code. I'm okay. I'm happy. I'm happy writing code." And the tester might well say, "Well, hold on. We've still got some anomalies to flush out, and we've got a session with the users, later this morning," kind of thing. And so you could perhaps use it to say, "Well, how are you thinking at the moment?" to identify schisms in the team understanding. And again, it's one of these things that a junior person might feel very reluctant to challenge a more senior developer, say, But I think if you've got the picture on the wall and just say, well, yeah, point to where you are and you're thinking about this feature. I'm over here. Oh, hold on. I'm over there. Something's going wrong here. Either someone is just there's a misunderstanding, or there's a real problem in that the team has a disputed view of status, if you like. So that's how I'm promoting it, and I think it's useful. I'm offering it as something that I think is useful.
So I think that your response overlaps with a couple of questions that we've gotten through from Charles Chandler and Scott Duquette around how you actually introduce this thinking to existing development teams and working with them if they're not quite in the same headspace in terms of continuous testing versus trying to execute it in a sort of waterfall fashion. I don't know whether you want to address that more specifically there.
Well, let me just sort of answer in an indirect way. I've presented this now to certainly thousands of people. I don't know how many, but there's like a good number on this webinar right now. And I have to say that there's only one challenge I've ever had to the model, and most people seem happy, but the challenge that I get is usually someone says, wait a minute, that's not new. And I say, good spot, absolutely, it's not new. And that's not a criticism. But if someone says, oh, that diagram, I kind of understand it, that's not new to me, I'd say, well, maybe it reflects how you think, maybe it's right. So the challenges I've had have been, that's how I think, So, okay. So now how do you map that to the behaviors that are taking place in a team that's doing continuous delivery or a, more understandable agile kind of environment, or even waterfall? I don't care, because it's independent of logistics. I said I didn't care what process you follow. So what I'm trying to suggest is that when someone is doing let's go back in history a little bit and say they're doing a formal review, they're doing reading of the document, they're doing mental modeling to assimilate the content of the document, they're coming up with examples, which then they can use to challenge, and they can say.
Let me just jump in a second, Paul, because there's another question that sort of alludes to what you're talking about now. So we're in an organization, this is from Anwar Parker. We're in an organization that may still be regarded to be in its infancy stage, and testing can be quite a cumbersome experience when trying to gather requirements, which is kind of what you're talking about, right? How do you think this would be overcome? So it sounds like you're sort of digging into the detail there of what that might actually look like in terms of analyzing requirements, right?
Well, one of the things that non-testers, i.e., managers and maybe developers sometimes too, they think, well, why is testing taking so long? Why do the testers take such a long time to do what they're doing? After all, aren't they just running tests? And so what the model tries to illustrate is that the process of executing a test is what I've called applying on the right-hand side. And applying could be using test automation, whatever, but there are 9 other thinking activities associated with execution. And so the tool is only doing what the tool can do. It's doing a mechanical process. It's applying some logic, predefined logic, to run a test and to evaluate an outcome as a pass or a fail, typically. Whereas the number of activities a tester has to go through in order to create a trusted piece of test automation is the previous 7 or 8. So when someone says, testing takes too long, well, where is all the time going? I think the testers could say, well, wait a minute, we're spending an awful lot of time asking what people think are stupid questions right at the very beginning, because we don't have a clear definition of the requirement, of the need. And the developer saying, well, I know enough to write code isn't good enough. It's got to be a trusted, shared, common understanding of the requirement, because the tester can't do their job, and they will be spending all their time asking questions while the developer's writing code that's probably misdirected. And where the hell does that leave us? So the way I would suggest that if you are under pressure to deliver, quote, more testing, unquote, would be to use the model to identify where all your time is going. And it could be that you are getting you've got a very poor source of information right on the left-hand side. It could be that you've got lots of anomalies, and you can create dozens of examples of requirements that are vague, ambiguous, conflicting, gaps, and the developer will still write code, can still write code with conflicting requirements. So maybe the model will help you identify where your time is going and where the bottleneck actually is. And the bottleneck quite often will be poor requirements. It will be people not answering queries about anomalies in requirements, or you're just not having enough time to think the requirement through in order to build it on a, to trust it so that you can build it. So the model might help there. So that's how I would suggest you might think about it.
Okay, so couple more questions, I think, before we close. There's a couple of questions around documenting test cases in continuous delivery models. Are there any best practices? I guess the answer is probably going to be it depends, but what are your views on that, Paul?
Right. So I said in my thinking that I don't care whether you document or not. And let me just explain that for a second, and then you'll see where I'm coming from. I don't care whether you document it by writing it down on a piece of paper or putting it in a spreadsheet or writing it into some neurons in some part of your brain. I don't see the difference. The act of documentation is a piece of logistics. So my question, I'd have to bounce it back and say, well, what is the purpose of that so-called documentation? Is it there to be a record of what was planned or what was executed? Or is it a document to support somebody else's thinking? So it's got to be written in a format that people can then take and reuse, if you like. So I would always almost sort of not answer it by saying there are good practices or not. I think you need to understand the people fall down because they're writing documentation with no purpose or a purpose that is foolish. If you are going to be audited, yeah, maybe you have to document everything. Fine. Continuous delivery may not be the way to go because you physically haven't got the bandwidth to do some stuff that maybe auditors would like to see. Yeah. But again, what auditors really want to see is they want to see what decisions are being made day to day and on what evidence they are making those decisions. And that's kind of what auditors really want. They don't want a mountain of paperwork. They want to know how you got from A to B and whether it was in a systematic way based on trusted information. That's how I would view what auditors do. And if you can get trusted information by capturing it through automated tools, well, fantastic.
So to summarize, document to the extent that it makes sense for your context and document it for the people that are actually going to read the documentation.
Yeah.
Okay, last question. Elaborate more on the automation. Everyone says automation is a part of this. What kind of automation are you talking about? That's from David Tagella. Do you want to, so part 2 of this continuous testing series is going to be more focused on the automation aspect of continuous testing. Do you just want to give us kind of a sneak preview, a taster of what that might look like?
Sure. I think, for example, if developers, you'd expect developers to do either test-driven development nowadays, or to make use of a BDD tool, Cucumber, SpecFlow, that kind of thing. But the tests they're applying partly are how they think about the construction of the software from the requirement, but partly the tests that are applied in this test-driven approach might be suggested by the testers, and be an output from their thinking about the requirement in the first place. So that the automation that I'm thinking of is your traditional TDD unit testing stuff that would be implemented using BDD type tools, Cucumber, SpecFlow, and so on, that kind of ilk. And then there's the API testing, so where functionality is delivered as services. You might do API testing on the services, then using tools. And on the GUI, what you really do want to do, and this is the testing pyramid in a nutshell, is you kind of want to minimize the dependency on GUI-oriented tests, because they are flaky. They exercise an awful lot of the software, but don't give you as much information as you need. But you do need confidence that the bits, the components that have been assembled actually integrate and deliver a good customer experience. And I haven't mentioned customer experience, but that's part of the scope of what testers have to do. How do we judge whether the users are actually going to go from end to end in a software product process to hand over their hard-earned cash to buy products or services? Testing is, some of that is done through monitoring in production, but some of that notion of customer experience will have to be done manually by testers. Some, a subset, could be done by tools. So it spans the whole. It's the whole, gamut of types of testing. There are contributions for most of them from some form of automation or another. It's not all system tester created automation. It spans from developers right through to operations. It's the way I look at it now.
All right, excellent. So Paul, you'll be back in around a month's time to talk about all of the stuff that you just mentioned and more, no doubt, in part 2 of the continuous testing webinar series. We'll also be publishing an ebook outlining some of the stuff that we've talked about in these webinars in due course as well. Paul, thank you so much for putting this together for us.